Okay, last one for the day. Determine if the graph can represent a polynomial function. Oh, sorry. This is question number 30. Oh, now this one is a 3-point problem. So let's try this. Determine the minimum degree. Now look, how many turning points do we have? I like to draw stuff. Let me draw that. Look at the graph. The graph is a curve. Ooh. So we have 1 turning point and 2 turning points. We have 2 turning point. So that means the degree must be bigger than 2. Okay, so it can be 3, it can be 5, it can be 7. I'll say determine the graph. Determine if the graph represents a polynomial function. Oh yes, it does. This is a polynomial function, and the minimum degree I will tell them is 3 because we had how many turning points? We had 1, 2 turning points. So I'm going to say 2 plus 1, well, that's 3. We're going to have a minimum degree of the polynomial is 3. Okay, continue to the next part. Leading coefficient is blink, and the degree is blink. Leading coefficient must be positive. Why? Because look at the general pattern. This graph is going, it's doing some stuff in the middle, but in general, this function is going up to the right, right? As you keep on going to the right side of this x-axis, the function value will keep on increasing. The right end is increasing. This means, in general, this is an increasing function. So this is how we know the leading coefficient is positive. And then the degree must be odd. Why? Because the left end behavior is going down. To the left, this is going down. And to the right, this is going up. The end behaviors are doing opposite. Opposite starts with O. That's how I memorize it. The degree must be odd because the end behaviors are opposite. Next part. And the very last part is asking us to approximate the real zeros of a function, determine if their multiplicities are even or odd. If there are more answers, then separate them with comma. Okay, to find the zeros, we need to look at all the x-intercepts. So let's see if we have any x-intercepts here. How we do? We have one intercept at -1, another one at +1, and 3. Guys, I better write this down. Okay, hold on. X equals -1, X equals 1, and X equals 3. These are the x-intercepts, as you can see. And here's one thing that I want to talk about. At each of these points, you guys see the graph is crossing the x-axis. See, the graph is crossing to the other side, crossing to the other side, and crossing to the other side. What does that mean? Okay, crossing x-intercept means then the multiplicity must be odd. Okay, the multiplicity must be odd because if the graph bounced, if the degree is even, it would have bounced or just simply touched. So I'll go and tell them that down in part C. They said approximate the real zero with even multiplicity. I'm sorry, but we didn't see any bouncing part, so I'll tell them none. But for odd multiplicity, we had the graph crossing to the other side of the x-axis at these 3 points, wasn't it? So I'll tell them that these 3 all have odd multiplicity. And that is it for this problem, I believe. And that was number 30 that we just did. So I'll submit the assignment to see if it doesn't show up. Because if we do the quick retake, we should be able to only do the ones that we did not get right. So if we answer number 30 correct, then it shouldn't show up again on our practice test. See, we can't access that anymore. That means we did it right. That's enough for me today. I did 5 problems, recorded 5 problems. I may come back and do a couple more tomorrow. to cover all 20 to 40 that one student asked about, but I'll be back later and probably do more, maybe tomorrow.